How to get more out of your Variac. That is what we'll talk about today. So for a recent update video on the Jazz tube amp build, I went over the usage of a Variac for testing equipment. Though there's a little bit more you can do with a Variac if you're willing to just go a little bit further. And that's to extend its usage by making a variable DC power supply. So if you didn't catch the last video and are unfamiliar with what a Variac is a big inductor that changes the voltage that we have coming out of our AC lines. Some look at it as a resistor, but in all actuality, it's really just a big inductor that has a wiper just like a potentiometer. And as you turn the knob on top, that will vary the voltage that comes out of the wall. Now, one thing to keep in mind is because since the Variac is a large inductor, it does accumulate some inductance, and that therefore will increase the voltage output of your Variac. So say for instance here, even though I only have 120 going into my lines or into the input of the Variac, I actually get upwards of 140 volts output out of the Variac. So that's one thing to keep in mind when you're testing equipment. You typically don't want to turn it up all the way because you will likely be over voltage at that point. But here, what I have is a recent DC power supply I constructed to extend the usage of my Variac. If you're one of those that needs a higher voltage power supply to test equipment, say if you like to work on vacuum tube amplifiers or you like to design vacuum tube amplifiers, this is a great resource to have on your bench. As many of the variable DC power supplies that are sold on the market for electronics labs only go up to 30 volts. If it's a dual supply, you can put those supplies in series and get 60 volts out of it. Though, of course, that's still not enough to power the average vacuum tube. But this gives us the ability to do so. Now, there are some kind of cool things going on in here that I want to talk about, and we'll go on the computer and I'll show you the schematic and I'll show you how I constructed some of this. But I just want to note that this is a dual supply. So I'm getting 120 volts out of each of these banana plugs here. Each one has a post for itself and it has LED indicators, which I'm also using as drain resistors, which I talked about in the Jazz tube amp video update. So those LEDs will aid in eating up all the voltage, draining all the voltage when you turn this off. So that way it makes it safe to operate and safe to work on, and safe to be around, so that you're not worried about having high voltage equipment storing energy for long periods of time. So with this having dual power supplies, I can not only get 120 volts out of it, but I can actually put these in series and get 250 volts out of it, which makes it great for, say, testing and designing tube power, for example, and tube preamps. Let's go on the computer and look at the schematic. Okay, so before we go over the schematic, I want to mention the transformer I'm using to make this dual power supply. So if you're unaware, one of the things that you need if you're going to make a power supply from a Variac or just anything that's coming out of your walls and you're not wanting to step up or step down the voltage, you still need a power transformer. You need what's called an isolation power transformer. So why do you need an isolation power transformer? It's because you need something to isolate your projects or whatever you're trying to power from the voltage coming out of your wall outlets. Now, the reason for this is because ground in the US and many other countries is typically tied to neutral. So there is a possibility of voltage potential getting to your circuit from ground. And that will also cause ground loops when you're going into test equipment like an oscilloscope, for example, which is also grounded to earth. Now, ground loops in isolation and the way AC power works is a large discussion that goes beyond the scope of this video, but this is one thing to keep in mind. And if you're not understanding what I've said thus far, then I would encourage you to go look up some other videos or look up some more other resources that have to do with isolation transformers, why you need one, and how ground loops occur when using AC power. But this is crucial. Again, if you want to do this, you need an isolation power transformer. So you can see here, I went with an isolation power transformer because I didn't want a supply that was too large, meaning one that went up to 300 or 400 volts. I also didn't want to spend a bunch of money on a large power transformer, nor did I want to build a large unit for this dual power supply. So I went with an isolation transformer. Now again, an isolation transformer does not step up or step down the voltage, it only isolates the voltage. So if you have 115, 120 coming in, you'll have the same coming out. Now, what's interesting here is that I'm using this isolation transformer from Triad Magnets, which I purchased on Antique Electronic Supply, or some may refer to it as Tubes and More. I believe it went for somewhere around $15, so fairly inexpensive. Again, that's also one of the reasons why I went with it instead of going with a big power transformer. But one of the other reasons is that if you look here, it has an input voltage of 115, but that's in parallel, and then it has a series voltage of 230 for the input. So that tells me that this has two windings for the input. If we look at the schematic here, this is the input where you have your 115 here going to the black, the yellow and black wire, and then you have another 115 winding that goes into the primary as well, and that's your red and black and your green and black. Now the reason for this is, as it's articulated up here, is that you can wire it either American or European. So you can do your 115 or your 230. So this gives the transformer some versatility. Now, that is a nice feature, but you can also do something to extend the usage of this that's maybe a bit unconventional, but works great and is a great way to get more usage out of a transformer like this. And that is to flip it around and use the secondary that's indicated here with these two red wires, and use the primary as your secondary output. So in effect, you're putting 115 volts, 120 volts into this side, which would now be our primary, and now you have a dual supply of 115, 120 on your output. And that's the way I've wired this transformer. So I'm using it in reverse. Now that gives me the ability to have two separate power supplies wired up to this thing, as I'll show you in the schematic in a second. Now this Transformer also has something else that can be very useful and beneficial, though not in this situation. But it also might be something that might be advantageous for other projects, and that is it has an electrostatic shield. And this is often done on transformers of this kind to suppress noise. So this electrostatic shield, which is basically just a piece of copper in between the core of the transformer and the secondary winding that you would put to ground, and that would help suppress or reduce noise. Though for this project, I just have it capped off, I'm not using it. So let's go on and look at the schematic. All right, so here's the schematic. So again, now you can see that the transformer is flipped around. So the secondary is now our primary, and the primaries are now our secondaries. So again, it's a pretty simple circuit, but I just thought I'd share it because it might help someone at least save some money when they're trying to do this. Because again, using an isolation transformer that has a dual winding that you get 250 volts out of is a lot better than maybe spending 50 or 60 bucks on a transformer that gets 300 volts out of it. So again, a very simplistic circuit. This is now our primary. These are our secondaries. I have a bridge rectifier that's made out of 1N5408 rectifier diodes. Now these diodes are rated for 1000 volts at 3 amps, so we have no issues there. I have a 470 microfarad cap that's rated at 250. I would upgrade those and do a higher voltage, probably up to 400 volts, just so I'm not stressing out the capacitors. Because of this limitation, I will probably only operate this thing around near 120 or 220, excuse me. But the only reason I use these caps is because that's just all I had on hand. And again, I wanted this to be quick and cost effective. So moving forward, we have a 23K resistor. And if you're familiar with electronics, that is an odd number. What that is in actuality is two 47K resistors that are paralleled, and that gives me 23K of resistance, and that's only there to supply voltage to this LED on the end of it. Now, as I went over in the Jazz 2-amp video, this LED at the end actually does more for us than just indicate when the unit is on, but it'll also act as a drain resistor when the unit is turned off, and that will make the unit safe to operate, as it won't hold high voltages in it for many days. So once the unit is turned off, in about a minute or two, it will go all the way down, back down to 0 volts. So that's a very handy thing to have in a circuit. That's actually mostly why it's there. Our output of the circuit is going to be at this capacitor. Again, you can use a bigger capacitor if you want to have a little bit less ripple. You can put a resistor in here. You can put an input cap with a resistor and put another input cap here, and then push this back and put your LED further down in the circuit if you're worried about ripple. Again, this for me is mostly for testing purposes, so it doesn't have to be that clean. I also can clean it up, you could say post-production, you could say, or after it comes out of the DC power supply. So that's the circuit. Of course, both windings are identical, and that's how I'm getting 120 volts at each one. And again, the reason why I wanted dual supplies is that so I could put these supplies in series. I can connect this negative to this positive, and that gives me a whole 250 volt output. And I'll show you more of that on the test bench, and we'll look inside of it as well and measure some ripple. All right, so here's the inside of the Daul DC power supply. So as you can see, here's the isolation transformer. I have an IEC connector for my AC input. Here are my binding posts. And as you can see again, the circuit is very simple. It's just bridge rectifiers made out of these rectifier diodes and the resistors for the LED. The LEDs are mounted up here on the front. And then I have these two 470 microfarad capacitors. Now I'll hook up my test equipment and we'll read some voltages out of it, and we'll check out the AC ripple. So now I have it hooked up to my multimeter and my oscilloscope. Let's see if we can read some voltages out of it. Okay, so I'm going to turn on the Variac, and it's at 0, so you see there's nothing, no fluctuation in voltage. Now I'll slowly increase it. You can hear the relays of the oscilloscope are turning on. Now we have about 10 volts. Keep in mind I'm at 11 volts, but I'm only 5 volts on the Variac. So of course, not only with the Variac stepping up voltage, but of course having a DC power supply that's rectified and now has some capacitance on it with no load, the voltage will be a little bit higher than what I have coming in on the input. Let's continue. Let's get it to about, let's say 40 volts, and then I'll parallel, or I'll put them in series, and we'll see the voltage increase we get there. All right. So that is the left supply. Now I'll put it on the supply on the right, and we should get the same voltage. And we do, 40 volts. So our transformer is doing a good job. 40 volts on each side. Now, what I'm going to do is put this in series. Thankfully, I already have a jumper cable from my 30 volt supply, my Daul 30 volt DC supply that I can use for this. If you don't have one of these, you can just use a regular old jumper. But this is nice because it fits directly into the banana plugs. So all I'm going to do here is take one negative from one supply and put it to the positive of the next. Now the supplies are in series. Now when I measure them, instead of having 40 volts at each of them, I should have 80 volts at these two terminals. Let's look at the meter and see what we have. And there we have it, 80 volts. So our supply, our Daul supply, is now effectively in series. Now this is what makes having a Daul supply very cool. And again, we did that all with just an isolation transformer that had dual primaries that we used in reverse and used those two dual primaries as secondaries, giving us dual supplies that we can now leave floating, meaning that we don't have them tied to ground. And again, if I didn't mention that in the schematic section of this video, that's why I don't have them grounded. I don't have the supplies grounded or earthed because I don't want them to be restricted in their usage. I want them to be able to be what's called floating so that I can put them in series and extend the voltage range of both supplies. So let's go up and see how high we can get. We'll also zoom in here in a second and look at some of the ripple. As you can see, the ripple, it does have some ripple. So right now, let's get it to 90. At 90 volts with both supplies, with them in series, I'm getting a ripple of about 23 millivolts. So it's not that bad, but it's not that great either. Let's keep going. So we're at 100 volts. Of course, you know, the oscilloscope has to adjust, so it's going to dance around. We mainly want to look at the multimeter here. 130. Like I said, because of my restrictions with the caps, they're only 250 volts. So I'm only going to take it up to about 220. And we're about 150. Let's check our ripple. It's pretty high now. It's got to settle in. Still at 100, or still at 23. So let's keep going. 180. 200. Now at 200 volts, I'm only at 75 volts input on my Variac. $210. Let's take it up about 220. There we are, 220 volts, and I'm at about 84 volts on my Variac dual power supply in series. And that's how you can extend the use of your Variac. Now again, if I wanted to get less out of this, then I would just take out the series jumper, and I'll only be getting half as much voltage from the output. So I just took out the jumper, and I'm back to only measuring one supply, and I have 110 volts at that one supply. Now, again, as I talked about before, now I'll put the jumper back. As I talked about before with the LED, what that gives us the ability to do is have this thing drain at a decent pace, so we're not having voltage stay in this thing for days. So it makes it safe to have around and safe to work on and open up and what have you. So just as I did with a vacuum tube amplifier, what we'll see here when I turn off the Variac is that the voltage will start to decrease. Variac is off, and now you see it's just a matter of seconds. We're already down to 103 volts, 110, 190, now we're at 90, 70. So again, in a matter of seconds, now we're at 50 volts. And of course, as I showed in the vacuum tube video, the LEDs are dimming as this process is taking place. And it's been maybe about 45 seconds to a minute, and we're already at 15 volts. Now this thing is safe to operate, or this thing is safe to work on, have around. You don't have to worry about having a live 250 volt supply laying around. So that's all, ladies and gentlemen. That is how you make a dual DC variable power supply with the use of your Variac and a dual primary isolation transformer. Thanks for watching.